Hi, guys. I'm here to talk to you about earthquakes. I want to make sure that I've covered everything that you guys need to know. Um, I'm going to start off with a slideshow. First, you can see that there's a big earthquake there, and the roads have been destroyed. That happens quite often in earthquakes, unfortunately. So, I want to make sure you guys understand the difference between the epicenter of an earthquake and the focus of an earthquake. The focus is where the break actually occurs in the rocks. So it's usually pretty far deep down below the surface point. The surface point is called the epicenter. So it's kind of like an X marks the spot, sort of a landmark above the focus. So you would say the earthquake occurred at Huntington North High School, when in reality it might have occurred 300 kilometers down. So that's the difference between the focus and the epicenter. Earthquakes occur because the Earth's crust is kind of elasticy. It's sort of bendy and stretchy. So you can sort of see in this slide how you have a fault there. And then as plate tectonics begins to pull the rocks along the fault, it stretches, and then it stretches, and then try to figure out how to get this in the screen. It stretches and stretches and then stretches, and then it breaks, and it's in a new position. So you can sort of see how I've got move this. You can sort of see how I've got a picture here of it stretching, stretching, and stretching, and then it finally breaks, and now there's a new configuration of rocks there. It's called the elastic rebound theory, kind of like the old school stretchy, silly putty. We stretch it, stretch it, stretch it. Eventually, it's going to break. So that's how that works. We've already talked about earthquake waves quite a bit, but I wanted to review that and show you that there is a slide on that in case you need to study. P waves are the primary waves or the compressional waves. They're the ones with the slinky that I kind of push like straight forward and straight back. They'll travel through any material, and they're the fastest waves to reach the seismograph station because they're traveling in a straight line. S waves are the ones, they're kind of like shear waves that I showed you, kind of go like up and down like this. And they're slower because they're not traveling in a straight line. They're moving up and down. And if you stretch that out, it's a farther distance. Interestingly enough, S waves will not travel through a liquid. They're slower than P waves. And the fact that they will not travel through a liquid has taught us a lot about the interior of the Earth. We know that the interior, the very interior of the Earth, has a core, a liquid outer core, and then a solid inner core. We know that the outer core is liquid because the secondary waves will not travel through it. They stop when they hit the outer core. So that helps us learn about the interior of the Earth. We've already talked about L waves also. Those are the surface waves, and they kind of tend to go like almost like an ocean wave. It goes like this. And they're the slowest waves, and because they're at the surface, they cause the most damage. So those are important. Sometimes in an earthquake, you can see the ground kind of look like it's sort of lifting up like that, like an ocean wave. And those are the L waves that you're seeing. We did the virtual earthquake, so you were able to find the epicenter of an earthquake, and it does take 3 seismograph stations to be able to find the epicenter because they tell you distance but not direction. And you have to have 3 of those to figure that out. And here's an example. So you guys did this with virtual earthquake, and you were able to find the epicenter based on the difference between the P and the S waves on the seismogram. Good job on that. How do we measure earthquakes? Well, we look at how much damage they produce. That's one way, and that's called the modified Mercalli scale. This particular scale is This particular scale is created to describe how much damage an earthquake occurs. At 1, you don't feel it at all, and then you can sort of see as it goes along. When it gets up to 9, it's violent, like totally catastrophic. That's called the Mercalli scale. We don't use the Mercalli scale very much anymore because we can look at the seismograph and we can actually pinpoint how much energy is produced. So we don't need the Mercalli scale because it's very subjective. It depends on people's opinion about how much destruction has occurred. Also, we talked a little bit about, let me move me out of the way here, about the New Madrid Fault, or New Madrid Fault, it depends on how you pronounce it. The New Madrid Fault runs up through Arkansas, Tennessee, Missouri, Kentucky, and then up into Illinois and Indiana. So these are places that are close to us. This is a fault that we need to be aware of. We need to watch and make sure that it's not going to create another big earthquake. You can see that by using the Mercalli scale on this particular map that it was a very big earthquake. It got all the way up to a level 11, and 12 is the highest you can go on the Mercalli scale. So it was pretty devastating. We need to keep an eye on that fault. It's an interior fault. It's not on a plate boundary, but scientists believe that there is a plate boundary that's below the current continental plate, and that's what's causing the fault to move. And here's another picture of the New Madrid Fault here. Oops, let me move that out of the way. So you can see here, up here in Indiana, we are at a high risk for being affected by the New Madrid Fault. We're all the way up here, so we would probably not get nearly as much damage as they do in southern Indiana, but it's always a possibility that it could be higher. We don't know, so it's something to be aware of. Here's the Richter scale, which is something you guys have heard. I'm sure you've heard that term, Richter. And that is because a guy named Charles Richter back in the 50s created the Richter scale and put numbers on there, made it very precise depending on how much energy is being produced. So you can see that's kind of like the Mercalli scale, but 9 is as high as it has gone. There's no limit on the Richter scale. So could we have an earthquake magnitude 10? It's possible. It would cause catastrophic damage if we did. The ones that we have had that are above a 9 have literally shaken the earth on its axis. So if we had a 10, it's hard to believe what kind of damage that would do. And we watched The Impossible. That was above a 9 on the Richter scale. So that's why there was so much damage done there. Also, the one in Japan in 2011, or that was also above a 9. So these are catastrophic, very rare earthquakes. This is the moment magnitude scale. The moment magnitude scale is the one that we use today. And this one is a little more precise. You can kind of tell how much energy is being released over here. And then the corresponding magnitude over here. It's similar to the Richter scale. So you're going to have a 9 is where the absolute tallest or highest ones have occurred, produced enough energy there to totally destroy the area that they occurred in. The one in Chile that you read the article about, 123 trillion pounds of explosives. That's how much energy was released in the 1960 Chile earthquake. I showed you pictures of the Alaska 1964. That was probably around a 9.2, and that produced 4 trillion pounds of explosives in terms of energy release. So we're talking big time, big earthquakes. And the one that occurred on the New Madrid Fault, which is near us, they have here above an 8, 123 billion pounds of explosives in terms of energy released. That is a lot. It's almost catastrophic like these above. It's actually more energy than was produced by the world's largest nuclear test, which was done by the Soviet Union back during the Cold War. So that's a lot of energy. Earthquakes are something to be concerned about, especially since they're not predictable. And if you live in an earthquake zone, you need to know how to protect yourself. Most injuries result from falling objects or falling buildings. That's how people get hurt in an earthquake. If you're in an airplane, it's not going to affect you at all. If you're out in the middle of a field or a cornfield, it's probably not going to affect you at all. You might feel the shaking, but nothing's going to hurt you. Where people get hurt is when buildings fall or things inside the building fall on them. So it's something to be aware of. The Ring of Fire, that's where most of the earthquakes on Earth that are occurring now are occurring. It's the most active plate boundary on Earth. The Pacific Plate is active all the way around. So this is where we have our earthquakes and our volcanoes along in the Ring of Fire. These are the places people need to be most aware of earthquakes and volcanoes. And we talked about seismographs also. so you can see, hear how the seismograph works. And I think we did a pretty good job going over seismograms. We know this one got to the station the fastest. So that is the closest to the epicenter. The station is closest to the epicenter. This one has the most magnitude because you can tell that the lines are the strongest up there. What should you do if you get hurt by or hit by an earthquake? Drop and cover. So what you need to remember to do is to get under a table or under a sturdy object that is going to protect you from falling debris, like in a doorway where you have the frame of the door around you. Don't try to run out of the building because earthquakes occur very rapidly and everything's going to be falling on you. By the time you get out of the building, you're in more danger than if you had just dropped and covered. So what you should do in an earthquake, drop and cover. That's what you need to remember. And don't forget, you should always have an emergency first aid kit. Preparedness would include water for 3 days, food for 3 days, batteries, flashlights, things like that, that you can imagine you might need in case the power goes out for days and days, which would happen if we had a catastrophic earthquake here. Those things are important for you to have. Also, it would be good for you to have a way of communicating if the internet is down, if the phones are down, walkie-talkies that you can communicate with your family members. It's also a good idea to always have a plan of reunification. So if there's a natural disaster, a hurricane, or a tornado, or an earthquake that occurs, you and your family members should decide upon a place to meet up just in case it happens when you're in different areas. Somebody might be at football practice, somebody might be at work, somebody might be babysitting. So when a natural disaster occurs, if you can't call each other, then you should have a plan of attack. Like, let's all meet up at the McDonald's. Let's all meet up at our house somewhere so that you can get back together with your family members. It's a great idea. So that's it. That's pretty much everything I have to say about earthquakes today. And we're going to get busy with some more activities. See ya.